In my class, we've been doing double replacement reactions, and we've been figuring them out in such a way that we can actually take the two reactants and predict and write down what the products will be, and then balance the resulting equation. So, after you watch this, your journal might read, "Today I learned that following these steps will make it easier to do double replacement reactions correctly and get balanced equation." So, let's get started. What is the first step in doing this? First, you need to copy the molecules for the reactants. That comes from for instance, 2 with 8, and that's what we got from this little chart, and we found out what those products were going to be, or what the reactants would be. And so now we come down here and we look at the reactant side. The reactant side is iron 3 chloride, actually, the way that would be named, and this would be potassium chromate. So the thing that we want to do next is set up the other side to be what it's going to be, and these are the little underlines that we've been using for coefficients. So just put those over on the other side along with these, and now you're ready to start your predictions. So we want to copy just the cats to the other side. So what I'm going to do as we go along is I'm going to block off everything from prior screens as we continue into each future screen. So we've got our 2 with 8, and that's what we started with up here, and we put in the now iron and potassium because they are the cations, or the positive ions. Our next step is to switch the anions, which are chloride and chromate. So figure the charges on both cats first. So before we do that, we want to figure that. So let's look at this again, and let's bring all this stuff out of the picture and focus on just the things that we want to see. So right now we want to look at the 2 with 8 and this stuff and this stuff, and now we're going to figure out what does iron have to be. So we look here and we say that, see this subscript here? I just copied it down here because I want to know what iron is. Iron can be 2 different charges. So if I don't know what he is, I can't take him over here and balance him with something else. So I take this little 3 here. I know that chloride is a 1 minus, but I haven't got a clue what iron is. So I'm going to take the 3, I'm going to multiply him by that, which is the subscript, times his charge, which I wrote up here, and that's going to be equal to a 3 minus. So when I change this charge to a plus, presto whiz bang, I've got myself a 3 plus on the iron, which is why we called him iron 3 chloride. Now potassium, I don't have to figure that out because he's in our Memorize Ions project. So I know that he's a 1 plus because he's in column 1 on the periodic chart, and all those guys are a 1 plus. Then I look at chromate. He's from my Memorize Ions project, and by now we know that chromate is a 2 minus. So over here on the right side, where we have these guys, we want to put their charges down, and then we're going to, in the next step, switch the anions, which means we're going to put them over here with different cats, or the cations. So here we go. We're going to cover all of this, and let's just get now the equation written again, and let's get this all up to the top. So we're just looking at one thing at a time. So here's our little dude. Remember, he was a 3 plus, and over here he's got to be a 3 plus again, because in double replacement reactions the charges don't change. And the potassium dude is of course going to be a 1 plus. So let's just look now at this one thing. All right. Now, we're going to take this guy and put him with the potassium. And so the chloride goes over here with the potassium, and I want to have his charge up here because we're going to figure out the ratios of the cats to the anions. And here we're going to have our chromate, and we know that chromate is going to be a 2 minus. So to have a 2 minus, well, I'm going to write him in right now. So the 2 minus over there on the right is also going to be there on this side, or on the left is also going to be on the right. Okay, now I have my charges up here, so I can do the crisscross. I can say now that iron is going to be a 2. His subscript is going to be 2. And there we go. And the chromate is going to be, well, we'll do that in the next one. Let's go ahead and crisscross the right sides, the charges that we just figured out. And so let's put in the equation again down here. We know that potassium's a 1 plus, chromate's a 2 minus, iron's a 3 plus, and chloride is a 1 minus. So over here, the iron is still 3 plus, the potassium is still 1 plus, and now we're going to put in our chromate and our chloride. So now that we've got all of that stuff, we want to go ahead and figure out what the crisscross is going to be. And there we go. Now we got everything we need. So here the 3 plus is going to give us absolute value of 3 chromates. And we're also going to get, because of this 2 up here, a 2 subscript for the iron. Remember, it's always absolute value. So there's no negatives, there's no charges at all in subscripts. Over here, because this ratio is 1 to 1, I don't need any subscripts. So now I have myself a balanced equation. And of course, our next step is going to be to take what we've just created. Here, just a second. Here we go. And we're now going to figure out, first of all, what things we have on each side. And I'm going to take this back out for a minute and back in because I want to clear that screen and come on back down here. Now, the way I figure this guy out is I take him an atom at a time. So with the chromate over here with a 3 and the iron with a 2 and potassium here with chloride, we're ready to balance. I look at the subscript of this chromate over here, and I'm just going to take that 3 and I'm going to put him in right over here, because I'm going to balance the whole ion at one time. So when I put 3 over here, I have balanced my chromates, which is CrO4, with my chromates, CrO4. Now the next thing I want to do is look at my chlorides, because I'm going to balance with anions when I do this. And so my chloride is 3 over here. I'm going to make him, I would make him normally a 3 over here, but he's going to wind up being a 6, which you'll see why in just a moment. Because I'm going to have 6 chlorides, because I have irons here of 2, and so this guy is going to have to be a 2. So now I've got 2 irons, 6 chlorides, and 6 chlorides over here. Potassium is 6 because of the coefficient. Potassium over here is 3 times 2 is 6. Chromate is multiplied by this 3, so I've got 3 chromates here and 3 chromates here. And now, because everything is in balance, I have a 1 here, because we're just putting those guys in to get trained on how to answer multiple choice questions and see the proper ratio. Now we're done. We have balanced the entire thing, And even with a lengthy explanation, I've only taken 10 minutes. So I hope you're going to find that this is exceptionally helpful for you in doing this kind of an operation, which is to find, first of all, from the reactants, what the products have to be, and then ultimately balance it. And you got a situation where, if you want, anytime you could carry these numbers over, but I don't recommend it forever. Okay, we just want to do this for now, just to see it and know that we're doing the right things. And that's it. Thank you very much for watching. Save it.